Hello everyone, and welcome back to the Fluctus channel. Tugboats are powerful little vessels that have been an integral part of the maritime industry for over 200 years. These seemingly small boats are some of the most useful of all maritime inventions when it comes to bringing massive stranded vessels home. They are capable of moving ships 1,000 times their own size and weight through the tightest of situations with an incredible combination of sheer power and precision navigation. In today's feature, let us explore the secret behind these amazing maritime marvels and how they generate tens of thousands of horsepower to push, pull, and tow massive maritime vessels through ports, canals, shipping lanes, and the high seas. The secret to the tugboat's incredible pushing and pulling power lies first of all in the engines. During the construction, much emphasis is laid on the particular engine type each tug must carry. Many models feature high RPM diesel models that maximize propulsion and provide loads of torque. Though diesel engines are still the most common method of propulsion, some innovative companies have now found ways to get the same pushing power on tugs using only electric engines. Most tugs feature double massive tow winch engines with big shafts and at least 16 cylinders on both sides of the engine. Each engine drives one of two propellers in the stern, which are extremely oversized for the boat. They also sit very low in the water to generate maximum thrust as they displace water from down under. This generates more friction, more propulsion, and adds to the vessel's overall power. Of course, as the tugboat's job also necessitates excessive maneuverability, they were among the first boats to have propellers that could turn independently of the hull. Over the decades, tugboats have proven that they can do it all. From barges to cruise ships to today's biggest container ships and other shipping vessels, tugboats have been there time and time again. In order for a tugboat to successfully guide these big ships into a port to avoid collisions and damage, there is more to the process than just hooking up a line and starting up the engines. When a large container ship or cargo ship arrives at a harbor, the harbor pilot will rush out to meet it a few miles out. This person is highly knowledgeable about the barriers, obstructions, and other dangers in the water of their home port, and it's their job to work with the arriving ship captain, the crew, and the tugs to get the ship in and out safely. With some of the largest vessels, a lead tug will handle the steering via a rope or cable attached to the bow. In the meantime, one or more tugs will push from the rear in order to generate momentum. Tugboats are not like other ships in their requirements, capabilities, or performance. This peculiarity is prioritized from the very conception phase and becomes even more evident in their construction. Take, for instance, the Ocean Pierre-Julien, the 82-foot-long tug that was assembled in France in 2013. The process of building this twin-screw tractor tug was heavily modular, with prefabricated sections being fitted together with the help of large winches and cranes. The tug presently sails under the Canadian flag. An escort or harbor tug typically has a main winch on the foredeck and towing winch on the aft deck to enable it to carry out its main tasks efficiently. The winches enable braking or steering the escorted vessel out of danger in case of technical failure, acting as an additional rudder for the assisted vessel, or general harbor assist and deep sea towing. The main winch system, made up of massive tow ropes and powerful shackles, is ideally located in the center of the boat.
The reason why they have a winch more towards the center of the boat, or ahead of the rudders at any rate, is that if it's behind the rudders, it's really hard to turn. You can turn, but nothing really happens. So the further you get towards the center of the boat, the more the boat can turn and actually start pulling the barge in another direction.
Almost all industries require small, maneuverable vehicles that can push or pull heavy loads around. In the world of commercial aviation, that vehicle is the pushback car. Like with the large ships, planes are capable of rolling by themselves, but using the jet engines to do so would waste fuel, be extremely loud, and not result in very good maneuverability due to tight spaces and the absence of speed. That's where pushbacks come in.
We call this a pushback. It pushes up front and pulls at the back. Since airplanes don't have a reverse gear, they must be moved back to the main roller line again.
These are low-profile trucks, specially designed to push aircraft backward with speed and precision. To accomplish this, many of these vehicles use a tow bar that attaches to the front wheels.
There are different kinds of tow bar for various aircraft models. Airbus and Boeing are the most commonly ones used. There's a Dash 8 tow bar, for example. These are basically the ones we use most.
However, the latest models lift the entire front of the aircraft up, using a special hydraulic lift that attaches to the front tires. The operators of these vehicles take a lot of pride in their ability to use them properly. In fact, there are even interactive training games that give upcoming drivers a chance to practice without potentially damaging a $90 million airplane. Once they are certified, pushback drivers become a highly integral part of the airports at which they work. To move a plane, the trucks first get into position near the front of the aircraft. Once in place, a large pipe is fitted to the nose wheel of the aircraft and the front of the pushback truck. There are different tow bars for each type of airplane model, and they cannot be used interchangeably. For this reason, they are clearly labeled, and great care is taken to ensure the right one is used at all times. Once attached, the truck has full control over the neutral plane. And while this is indeed a heavy load, most pushbacks are actually capable of pushing up to 440 tons in one sweep. In the end, sometimes it takes a little help to move the biggest of vehicles. And this help usually comes from small but extraordinarily strong engineering marvels. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.